Hi there. If you want to challenge yourself and make a game in Unity, then in this series, we're going to be doing exactly that. So no matter if you have some experience in Unity or you're just getting started, I'm sure this series is going to benefit you. And instead of describing how the series is going to go, let's get started and you can see for yourself if this is the style that you're looking for. So we're going to start with the new project and I'm using Unity 2021.3. I will start with a 3D URP template, and this is going to create the 3D environment that I want for the game and also provide the universal rendering pipeline for us to make some post-processing in our game and make it look much better. Now let's specify our project name. I'll call it My Tractor Game. And let's create the project. I'm still waiting for the project to be configured, so I'm going to skip forward in the video. So here's our new empty project, and let's get started making our game. So first thing, we'll create a cube. This is going to be representing our player visual for now. But for this cube, we're going to create an empty parent, and the logic of the player is going to be inside here. So we'll call it player. The reason for this setup is so that we can easily change the visual of the player. So if we want to add some skins or actually some different 3D objects for our player, we'll just have to replace what's inside the player. But the main logic of the player, the movement and all of that is going to be unchanged. The other thing for the player, I want to change the tag from untagged to be a player so that if we'll ever need to filter out some events by tag, we have that configured for a player and that is ready to be done. And now we can start with our player logic. I want this player to move forward, and my forward is going to be the z-axis. So I want the player to move in this direction. We have several options that we can use to create the movement of our player. First one is to create a script that's going to be modifying the transform position on the z-axis, and that's going to create us the movement. And we can just do the incrementation every frame. If you're going to go with this approach, and then you'll have to create raycasting to determine if you hit any object and do all the physics calculations yourself. Now, the other option that we have is using the character controller, and the character controller has some functions like move that you can use to create that movement, and also have some configuration that we can set for our player. But the character controller does not have physics. So if you want your player to collide with other objects and detect collisions, you'll have to do extra work to detect that. The third option, and the one that we're going to use, is the rigid body. The rigid body is using physics simulation. So in here we have the option of using gravity. By default, it's turned on. And we can configure the mass, the drag, angular drag, and other configurations for the rigid body so that our physics calculation would be done appropriately. One thing to know about physics calculation is that in Unity, the physics calculations runs on fixed time, which can be configured in the project settings. Under time, we can look at the fixed timestamp. And here we have the fixed time for a physics calculations of 0.02 seconds, which is 50 times a second. Now the visual of the game is going to be run at a variable speed. I will take a look at that in more details. But now let's create our first script for the player so we can get the player to move. Inside my assets folder, I'm going to create a new folder. This can be the scripts folder. And let's go inside there and create our C# file. We'll call it player movement. Double click to open it. And as a C# editor, I'm using Visual Studio. And one thing you want to make sure that you have before you start coding with Unity is that you have autocomplete. So in my editor, if I start typing transform, you can see it autocompletes. And then if I click dot, you can see that I have a list of options that I have for the transform. Something like position, and that gives me the position. Now, if you don't have autocomplete or the actual name Intellisense, pause this video and go to the video link that is in the corner so that you can configure your Unity to have this option. It will prevent you from making a lot of silly mistakes, and it is a very useful tool to have working for you. Now, if you're new to coding, or you have just little experience, you don't have to understand everything that is going on in this video. The more you practice and the further along you get through this series, the better understanding that you'll have of how everything is working together. Now, I did make a short video of just things that you most commonly use in C#. The link is in the corner. I would strongly suggest you to watch that before we continue. And after you finish this video, you can watch that video again and see how much more you understand. Now that that is out of the way, let's look at the initial file that we have for this script. So our script starts with two functions, a start function and an update function. But I already mentioned that physics simulations works on a fixed delta time. And if we want to run anything at that fixed delta time, we can use the fixed update. So the rule that I try to follow to determine what goes inside update and what goes inside a fixed update, any visual changes or user inputs, you want to detect that inside of the update. But if you want to calculate your own physics, that's what you would do in the fixed update. The task that we're trying to achieve here is to get our player to move. And I do want to use the rigid body to control that. But for now, let's actually use the transform component. And since we're not going to be interacting with the rigid body, I'm going to just do it inside of the update. And the update is going to be called once per frame. So each time the image of the game refreshes, this method is going to be run. So we're going to look for transform.translate. And if we open the parentheses, you can see that there's some helpful information that we have here. And it is pretty nice to know how to read this. So it shows that we're looking at first option out of 6. It gives us a description of what the translate method does. So it moves the transform in the direction and distance of the translation. And you can click through these arrows to see what variables we can pass inside of this method to get our player to move in the direction that we want. So I'm going to use this one, which breaks up the vector 3 into x, y, and z, since we just want to move in the z direction. So we'll pass in 0 for x, 0 for y, and for z, let's say that we want to move our player 1 unit per second. So if we just put 1, that's going to be moving 1 unit per frame. And the way you convert from per frame to per second is by multiplying by delta time. So we can find that in time.delta time. And we can see the description of what delta time is. So it's the interval in seconds from the last frame to the current one. So whenever we will multiply a value by delta time, we're scaling that value to be in per second terms. So multiply by delta time, add semicolons, and now we can save this script. Let's go back to Unity. So whenever we change something in the script, when we get back to Unity, the script is going to recompile. So we have to wait for that to be complete. And now we can select the player and add this script to this player. So that is done. We can click play to test this script out. And you can see that our player falls down. But in the inspector for transform, we can also see that the z value is actually changing. So that means our script is working. And if we don't want our player to be falling down, we can turn off the gravity, click play, and now you can see that the player is slowly moving away from us. So that is how you can use the transform to move the object. Some of the places where you can use this approach is for objects in your game that don't interact with the player and don't have any physics or colliders. For this game, we can use it for something like clouds. So if we add clouds into our game, we can use this approach to move those clouds in the scene. But for our player, because we want to collide with other objects in the game, we want to use the rigid body to move it. For us to use the rigid body in our script, we need a reference to this component. The transform component exists in every game object, so our script by default has a reference to the transform, but the other components that we add to our game objects will have to be connected some way to our script, so with that we can access them. I'm going to show 2 ways you can do that, but first let's start by creating a new variable in our player movement class. So right after our class declaration, inside here we can create a variable. Since we want a reference to a rigid body, Our variable type is going to be rigid body. So if we start typing that, this is the type of the variable that we're trying to create here. And then after we specify that type, we can type the name for our variable. So you can call it whatever you want. I'll just call it rigid body. And for our name, rigid body, we get this squiggly line. And if we put our mouse over this variable name, you can see the reason why we get that green line. So it says player movement.rigidBody hides inherited member component rigid body. Use the new keyword if hiding was intended. Unity used to have a rigid body variable available for us to use just like transform, but that is currently obsolete, and that is why we're getting this warning. And you can go down here at the bottom and click on the warnings if you ever want to see all the warnings that we get here. If you have any errors, they're going to be in this list as well. You can ignore this warning and just continue writing your script. Some ways you can get rid of this warning is by changing the name of this variable. So you can call it my rigid body instead, or do what they specified here. So use a new keyword if the hiding was intended. So I'm going to use that approach. In front of our variable type, I'm going to add a keyword new, and that's going to get rid of that warning as well. Some side notes about name convention. Personally, for variables, I like to use camel case. So that means the first letter is always a lowercase, and any word following in that variable name will be started with a capital letter. That's called camel case. So that's what I use for variables. And for classes and methods, I use Pascal case, which means that all words in that method or class will start with a capital case, just like we see here. But you can use whatever is better for you. Just try to be consistent with how you name the variables and the functions. So now that we have declared a rigid body variable at the top, we need to pass the reference to the rigid body component that we want to work with. One way we can do that is inside of our start method, which is going to be called before the first frame of update. It's going to be called only once. And now in here, we can get our rigid body and then set it to equals to the rigid body component of this game object. So in this class, we have the option of getting a component. So look for get component, and then we need to add angle brackets. And in here, we need to specify the type of the component that we're trying to get, which is the rigid body. Since this is a method, we'll add a parentheses and add a semicolon at the end. So this line of code is going to attempt to find a rigid body component inside of our game object that has the player movement component. And if it successfully finds that component, it will set it to the rigid body. If our game object does not have a rigid body, then the rigid body variable will be set to null, which is what it was as the default. If we leave the code like this, then later on in our code, we might get errors if the rigid body was not set appropriately. You can add a check here and check if a rigid body is null and do some error handling. But the other option that we have is to require a specific component for this script to run. So just before our class declaration, we can add an attribute and say required component, parentheses, and inside the parentheses, we want to pass the type of a component that we require to have. So here we can say type of and pass the rigid body as the component that this game object needs to have for the script to run. Adding things like this does take a little bit extra of time when you're creating a new script, but once you start using the script, it can save you a lot more time for error handling and trying to figure out why the script is not working if the script internally requires some component to be present for it to run properly. Okay, now we can assume that the rigid body is going to be present. We can use the rigid body to move our game object. So we can comment out this transform translate to backslashes. Whenever we comment out, it's not going to be run, or we can just delete it since we're not going to be using that code in this script. And inside the fixed update, we can use a rigid body dot velocity, and we can pass the velocity that we want our object to be traveling at. There's different ways we can create that velocity. So we can use a new vector 3, and in here we can specify what we want for x value, so 0, y value 0, and then for z value we'll set it to 1. Since we are specifying the velocity is in units per second, so we don't have to multiply by delta time or fixed delta time. This will be sufficient enough. The other option that we have is to use vector 3 dot forward, that is the direction, and then multiply by speed that we want to travel, which is 1 in our case. So that is another way of setting the velocity. We take the direction and multiply it by the speed. This is going to be the approach that we're going to take. And let's save this script, go back to Unity and test it out. And you can see that our player is moving forward with the speed that we have specified, but it's using a rigid body now. Let's go back to our script, and I'm going to show the other way you can connect the rigid body component. So instead of connecting it in the start, we can allow the rigid body connection to be done in the editor. There's several ways we can do that. So the first one is by setting this variable to be public. If the variable is public, then we'll see that variable in the editor. By default, if we don't have anything written here, the variable is private, or if we specifically write private, that is the same thing. So private variables won't be seen in the editor. But if we add an attribute serialized field here, this will force Unity to serialize the private field, which will display this variable in the editor as well. So let's go back to Unity, and after the script recompiles, now we can see the option for the rigid body here. So we can drag this component and just drop it inside here, and that will create that connection to our rigid body. So those are the options that you have, but I'm going to use the first option in my case. In this script, we're doing something that you should avoid doing, and it is using magic numbers. A magic number is some value that you use inside of your script. So you want to avoid this and instead use variables. This one is our speed. So let's create a speed variable. We want our speed variable to be editable in the editor. So we'll add an attribute serialized field. This is going to be a value of a float. We'll call it speed. And in here, we can actually specify the default value that we want to use here. So let's set it to 1.5. If we press in float here after the number, we need to add a letter F for float. So that's going to be our default value, but we'll also be able to edit this value in the editor. Now, back here where we use 1, we want to replace this with speed. And this right here, vector 3 forward, is our direction. So let's create a variable for our direction as well and add a value here. So create a vector 3 direction. And for the initial value, we'll set it to vector 3 forward. If you want this variable to be editable in the editor, we can add the serialized field attribute, and that will give us the option of changing the direction. So here's our updated script, and we can test it out. We can decrease the speed or set the speed to negative, and it's going to change our movement. So we got our player to move. Now let's create our ground. So I'm going to create another cube here, and I'm going to add a parent object for this one as well. Call it ground. And we want to add ground tag for this object. So let's add a tag. Click add. A new tag is going to be ground. Then select our ground, and in the list now we have the option for ground. Select that, and for our ground we're going to move it down by -1 unit. So it's going to be right underneath our player. Now we'll change the scale of our cube. So let's make it 10 units wide, and in the Z we can stretch it as long as we want it to be. So something like that. I want to change the ground color to be green. So let's create a material, and this is going to be our ground material. So for the color, let's select green, something like that. And let's decrease the smoothness so that it's not going to be shiny, and add it to our ground. And there we go. We have a cube moving on the ground. Okay, so now I want to replace this cube with an actual tractor. So I'm going to go to Canny Assets, and in here in 3D, if we scroll down, we have a car kit, and there's some tractors here. So I'm going to use that blue tractor. You can download it. It's a zip file, so let's extract it. Go inside here, models, and we're going to use the FBX format. And we're looking for a tractor. So that's the FBX file. Drag it into our assets. And here we go. Now we have a tractor here. We can drag this tractor inside of our player game object, and that's going to add us that tractor. We can delete that cube, and the tractor is actually sitting on the 0 point of our y-axis. So let's move our ground a little bit higher. So I think it's 0.5 what we're looking for, so that the tractor is sitting right on the ground like that. Now the FBX file came with the default colors. So materials were created for all of those colors. And what we can do is select those materials and click Ctrl D to duplicate those materials out. And now if we select on the tractor, go to materials. In here, we can use the materials that we just created to connect the import configurations. And if we click apply, instead of the tractor generating all those new materials inside here, it's going to be using the materials that we just duplicated. So that's going to allow us to modify those materials separately. So now we can actually choose a blue color that we want our tractor to use. So paint yellow, car tires, plastic. For the plastic, I want to use the same color. So let's go back here and copy a hexadecimal value here and go back to plastic and paste that in. And for the windows, we can actually add a blue tint to it. So something like that. So here is our tractor. Now we have a lot of materials that we've created already. So let's create a folder for it, materials, and select all of those materials and put them in the folder. Also, we can create a folder for our FBX files and move our tractor inside there. Select a game view, and for our main camera, we can go under environment, and here let's select a solid color. And for a solid color, let's use a blue sky. Now what we can do is actually put the camera inside of our player so that the camera is going to follow the player, and we can move it closer to our tractor, pick it up a little bit, maybe change the angle in the x-axis for it to look downwards more. So that's a quick camera setup. So we can click play now and see how the tractor is traveling. The Z value of our position is changing, but we can't really see that the tractor is moving because the camera is following. If we change the direction and get the tractor to move in the X direction as well, you can see that the tractor is actually moving. Now let's create a game object, a cube, and this is going to be just a temporary obstacle that we're going to add here. Now, if we play the game, you'll see that nothing happens once we hit that cube. And that is because we don't have a collider created for our tractor. So when you create a cube, we use the cube for ground and cube for an obstacle. You get a box collider for it. And the tractor doesn't come with a collider. So we'll have to create our own collider. I'm going to use a box collider for it as well. So we can click edit option right here and change the view. I'm going to switch from perspective so I can outline the tractor much better. So this is going to be our shape of our collider. And now let's do the same thing in the top view. So I want to scale both sides the same, and I can do it by holding Alt and creating a collision shape. So it's going to follow the front wheels, and we'll ignore those back wheels. Now, if you do want to create a more of a complex collision shape, you can actually add another box collider here, and you can add more details like that. So if we want those wheels to be included in the collider, we can do something like that. And both those shapes are going to be considered for a collision. Now let's make sure that our side is actually a bit more correct. Something like that. So that will provide detail for those back wheels. And you can do the same thing to get rid of this extra part here as well. But I'm just going to leave it at that. Let's go back into perspective view. So that's our tractor with the collision. And now if we play the game with those collisions, let's increase the speed of our tractor. Once the tractor hits that obstacle, it stops because we are using a rigid body for our tractor. And a rigid body can't go past a stationary object in your scene. Okay, so we got the obstacle and the tractor is now colliding with the obstacle. It's time to get some inputs so we can avoid that obstacle. So let's go to our player movement script. And in here, we'll start by listening for an input from a keyboard. If we want to listen for a specific key when it's pressed down, we can go to input.getKeyDown. And in here, we can specify the key code of the key that we're listening for. So for instance, if we want to listen for a D key, we can pass that in. And when we hit the D key on the first update, when that is true, we can execute some code here. So that's one way you can build this. But the other thing that we can do is go to input and we have an option of getting an access. So inside here, we can pass in a string of what access we're trying to get. And that will give us a value of a float. Now, the list of those axes that are available, you can go to project settings and under input manager, we have axes. And in here, you can see that horizontal axis is the left and right, and also it listens for alternative A and D keys. And the vertical one is down and up, and also listens for S and W. So we're going to use the horizontal axis, and we have lots more options that are available here. Now you can see a message right here at the top. This is where you can configure the controls to use in the Unity Engine Input API. And here we have a consider using the new input system package instead. So Unity has a new input system package that you can install and use that instead of this input system. But let's start with just using this one first, and later on we can go and configure the new input system instead. So let's go to our script. The axis that we're looking for is horizontal. So let's put that as the input axis that we're getting. And the value for this get axis is going to be from -1 if we're moving into the left, to 1 if we're moving to the right, and 0 if we're moving straight. Since we're using get axis and not get axis raw, the value is going to be actually smoothed. It's not going to be exact value of -1, 0, and 1. As soon as you press the key, it's going to increase the value to 1, and if you let it go, it's going to start decreasing to 0. It happens pretty fast, but it creates a more smooth input. If you don't want that effect, you can go with the raw input, and that's going to go from -1, 0, or 1 values. Now, the way that we're going to control this tractor is actually just rotating the tractor. So we can use the y-axis to rotate it, and I'm going to limit how much rotation is allowed. So let's start with a limit of -30 degrees to 30. That's going to be our rotation limit. But one problem that we have is if we rotate the player, you can see that our camera is also rotating. If that's the effect that you're looking for, you can just leave it as is. But if that's not what you want, if you want to rotate only the tractor and leave the camera to be always facing forward, then instead of rotating the player, you would rotate the tractor model. For that, we'll need to be able to reference this tractor object inside of our player so that we can control the rotation that way. Another option that we can do is keep the rotation on the player and move the camera outside of our player and create a script that's going to be following the player only in the Z direction and ignore all the rotation and position changes on the other axis. And if you want more smoother and more control and options for your camera, you might consider switching to use a cinema machine camera, and that will provide much more options for controlling your camera that way. But for now, let's keep it simple and just rotate the player. And then I'm going to switch to use a cinema machine for camera and make the game smoother. So back to our script. In our script, what we want to do is use this get axis and set the rotation of our player. Rotation is part of the transform component. So we can say transform dot rotation equals to, and here is where we need to do a calculation. So we want to do a new vector 3. We're gonna keep rotation of x to 0. And for the y value, we're gonna pass 30. That's the amount of degrees we want to rotate. And for z, we'll set it to 0 as well. Multiply that value by the input get axis, and we get an error. We can see that cannot implement a converter type from Unity Engine Vector 3 to Unity Engine Quaternion. So in Unity, the rotation is actually stored in a quaternion, but what we see in the transform rotation here is a vector 3. So we need to convert this value to a quaternion so we can pass that value for the rotation. And the way we can do that is access the quaternion class. And here we can use Euler, and the Euler option can accept the vector 3, and that will be converted to a quaternion, which can be set to the transform rotation. Now we have a magic number again here. So let's convert it to a variable. So we can do a quick action refactoring and just use the introduce local new variable. That creates this line right here, and we can name our variable here. So let's call it rotation limit, but we want to move this out and put it right here in our class variable declarations, and we can add a serialized field here. So that's going to be another option that we can modify in our script. Let's click save and test it out. And we can use A and D keys to rotate our game object, but you can see that the direction of our movement is not being changed. So let's go ahead and do that now. So we're already using a direction variable here when we are setting the velocity. The default value is forward, and we can configure the direction in the editor. But for our player, we want to control the direction based on the rotation of our tractor. So let's remove this variable. We're not going to be using that. And for direction, we're going to use the direction of our tractor. So the way that we can do that is use the transform component. And in the transform component, we can do a forward direction, up direction, or right direction. But we're looking for the forward direction of our player. So save that, and we can test out the game. So now if we change the rotation, you can see that our tractor is moving in that direction. So now we can avoid the obstacle. Let's try it one more time with faster speed. So now we can control our tractor. But that camera rotation doesn't look that great. So let's actually rotate the tractor instead. For that, we'll have to create another serialized field. And we can use either game object or a transform here. Since we're going to be using just the transform component of the tractor model, I'm just going to use the transform type. So let's call this tractor. And what we need to change in the script is what we're rotating. So we're going to be rotating the tractor and also use the tractor's forward direction. Save that, go to our player, and now we need to connect the tractor game object to the tractor variable. Let's test it out. And now if we rotate the tractor, you can see that the tractor is rotating and the camera is just following the X and the Z axis. Good job. You have made it to the end of the part 1. And before you go to part 2, whenever that's going to be available, you can go ahead and use the settings that we created here to configure the tractor how you want it to move. And also you can try adding more obstacles to make the level a little bit more interesting. So just try to explore with what you learned and see what you can create. If you want to support my work, there is a Patreon link in the description, and any support is greatly appreciated. In the next part, I'm going to show my settings and how I configured my tractor, and also we're going to add lots more to this game. So see you in the next part.